Hello everyone. Today I will be talking about a great topic in database management system, which is transactions. Transactions are set of operations that are used to perform some logical set of work. When you are doing some particular set of work like inserting new data or updating the data or deleting the data, it all of these are transactions. Now, in transactions, the integrity and the consistency of data in the database should be ensured. That's why database management system maintains those four properties known as ACID properties, like atomicity, in which the whole transaction is considered a one. It either commits or it is rolled back. Second is isolation, that all the transactions are independent of each other. Third is durability, in which the transactions are fail safe. And the final one is consistency, that that the state of the transaction is consistent before and after the transaction. Now talking about state diagram. State diagram is a visual representation of different states that a transaction can go through its execution. Now there are some regulations and there are some states in which the transaction can go and it will finalize whether it will commit or it will abort. Now type of states in that state diagram. First is active state. If the transaction is in execution, then it is said to be in the active state. It can be read or write. Then second is partially committed state. When the transaction is committed or performed on a local memory rather than the actual database. So it is known as partially committed state. So it is done so that the actual database might not lose any data. Now failed state, when a transaction is failed, then the transaction is known as the state is known as failed state. Then there is committed state, when the execution of a transaction is successfully done, then the changes from the local memory are done in the actual database. So it is a committed state. And this is the state diagram. And along with that, I will be talking about the aborted state. So when a transaction fails, it goes from the failed state to the aborted state, and then the whole transaction is terminated, as you can see in the diagram. Now talking about database management schedule. It is a series of operation from one transaction to another transaction. Like we have schedules for different activities, or we have schedules for flights, trains, buses. It is similar to that. Instead of the buses, we have transactions. So in this is performed concurrently, but still there is a sequence. Like as you can see, there are two transactions, transaction 1 and 2, and there at time t1 only read x is performed, at time t2 only read y is performed, and later on at t3 write x and t4 write y. Now types of schedule. First is serial schedule. In this, a transaction is executed completely, and then another transaction starts. As you can see, first the changes in A were made, and then changes in B were done, so that the transactions are separate. Now database management schedule. Second is non-serial schedule. it has different orders, uh, the order does not matter here, that's why it is non-serial schedule. And there can be multiple transactions which can be left behind or which are interconnected. It does not wait for the previous transaction to complete. Now, talking about strict schedule in non serial schedule, if the write operation precedes a conflicting operation read or write, then the commit or abort operation of such transaction should also precede conflicting operation of other transaction. Now, strict schedule. Let's see, we have TA and TB. If write operation of TA precedes the read or write of TB, then the commit and abort should also precede read and write of TB. Now, cascadeless schedule. A cascadeless schedule, if the transaction is going to perform read operation on a value, it has to wait until the transaction who is performing write on that value commits. That means if transaction T1 is committing is writing transaction A, then unless and until it commits that, another transaction cannot perform read operation. Now, recoverable schedule. Uh, the transaction can commit the value only after the other transaction has committed the value which had uh, been using that value. Now, serializability. First is conflict serializability. It checks whether a non-serial schedule is conflict serializable or not. It is conflict serializable if it can transform into a serial schedule after swapping non-conflicting operations. Now, there are three conditions for that. First is both the operation belongs to separate transaction, both works on the same data set, and at least one of them is write operation, like write, read, write, read. For example, here you can see there are three transactions T1, T2, T3, and there are 6 time zones T1 to T6, and we are performing read and write on two objects X and Y. Now, for transaction T1, we will compare transactions of T1 to T2 and T3. Now, for time T1 and T2, there is no conflict because the objects are different. Now, talking about time T1 and T4, there is also no conflict because the objects are different. In time T4 and T5, there is also no conflict because the objects are different. But in time T1 and T6, there is conflict because we are reading, one is reading X and one is writing X. As you can see, uh, transaction T1 is writing X while transaction T2 is writing the X. So we draw a arrow from T2 to T1 in the diagram, precedence graph. Now for transaction T2, comparing T2 and T4, we get a conflict because it is one is reading Y and other is writing Y. So we draw a arrow from T3 to T2, and rest there is no conflict. So no arrow is drawn. And in final transaction T3, there is a conflict in T5 and T6 in write X and read X. So an arrow from T3 to T2 is drawn, which was drawn earlier. So we did not drew any other arrow. Now, since it is the precedence graph is not in a loop, then the uh, schedule S1 is conflict serializable, which can be serialized. Now